Sir, can I get started with the class?
Yes, Guru.
Okay, yeah. So, can you see my screen, everyone?
Yes, sir.
So, Tatvatika sent me a doubt in WhatsApp, so let's quickly discuss that. Ninth question. Moment of inertia of circular disk of mass. So, circular disk, so disk naka, it's like filled with material, not a ring. So, understand the difference between ring and a disk. So, the radius is mass is m and the radius is r. About an axis passing through the center of mass is I naught. So this is I naught. Again, they didn't say which one is the axis, they simply said some axis. So the moment of inertia of another circular disk of same mass and thickness. Same mass and thickness, but half the density. So density is half. So that means density less means volume will be more, right? So that means I think it will be like same mass and same thickness. So that's your thickness here. So here also they said you are having the same thickness here also. But mass is same. Density is half. So if this was density rho 1, this will be rho 2 is half the density. So rho 1 by 2. So here density would be mass by volume. So mass by volume. So volume will be pi r squared into h. H is this thickness T. So carefully understand, they said mass is same, radius, mass is same, thickness is same. They didn't say anything about radius. So which means the radius will be higher here because less density means to achieve the same mass, you have to put more, more material, I think. So for example, if this was iron and if this was aluminum, to achieve the same mass, iron will be like rigid, like, higher density, whereas aluminum will be lower density, which means it will be occupying a bigger space. So mass by volume. Volume is pi r2 square. Here maybe I can write as r1 to avoid confusion. R2 squared into thickness T. Rho 1 is nothing but this one. So in place of rho 1, I can replace it with this one. So m by pi r1 square into T. Then don't forget there is a 2 in the bottom. So that means this 2 will be coming here. Mass, they said it is same, so mass gets cancelled out. Radius is not same, pi is same, thickness is same. So basically I don't know R2, so that means R2 squared is equal to 2 times R1 square. So R2 is equal to root 2 into R1. So that means now if I want to find the moment of inertia above the same axis, let me read the question. I think they said the same about the same axis as, so that means it will be moment of inertia here will be m r1 square divided by 2 for disk. Okay, this is the formula for a disk. You can go back and check it in your handbook. So in the same axis, mass is same. It will be r2 square divided by 2. R2 can be written as root 2 R1. So that means it will become 2 times R1 square. I know m R1 squared by 2 is nothing but your I naught. So that means it will be 2 times I naught. So D is the correct option. So that means you see this part is very, very easy. The part which is difficult is to understand that m and thickness is same, but radius will change because they said density is changing, which means you have to come up with this method and then find out the relationship between R2 and R1, and after that it's very easy. Is that okay?
Yes, sir.
Okay. In the steps density vechi pandrathu.
Yes, sir. I didn't consider that the radius also will increase, sir. So I didn't get the answer.
Yeah. So since they didn't say anything about radius, you should get a clue that maybe density change agudhu appadina radius and change agum, because mass they said it's same, right? And thickness is same. So that means the radius will be higher. As I guessed, இது வந்து அயன் மாதிரி அசியூம் பண்ணிக்கோங்க, இது வந்து அலுமினியம் மாதிரி அசியூம் பண்ணிக்கோங்க. So iron is compact, aluminum is, to achieve the same mass, aluminum will be occupying more space. Yeah. If you have that kind of imagination, it's easy.
Okay, sir.
இப்போ நான் ப்ராப்ளம் ஸ்டார்ட் பண்ணுறதுக்கு முன்னாடியே ஐ ஷுட் நோ தட் இது வந்து பிகராக இருக்கும் அப்படின்னு தெரியணும். ஏன்னா டென்சிட்டி வந்து ஹாஃப்னு சொன்னாங்க. அப்போது இது பாருங்கள், இது வந்து 1.4 times R1. அப்போது திஸ் இஸ் பிகர். சப்போஸ் பை மிஸ்டேக் நான் வந்து R1 by root 2 எழுதியிருந்தேன்னு வச்சுக்கோங்க, ஐ ஷுட் நோ தட் இட்ஸ் அ மிஸ்டேக். ஏன்னா R1 divided by 1.4 R2 value will be less than R1, which is not correct. And that is what I called as reality check. ஸோ நீங்கள் அந்த இமேஜினேஷனோட கொஞ்சம் வந்து ஓகே இதை விட இது பெருசாக இருக்கும் அப்படின்ற இமேஜினேஷனோட பண்ணிங்கனாக்கா வர்ற ஆன்சரும் கரெக்டாக நம்ம செக் பண்ணிக்கலாம். இல்லாட்டி என்ன ஆகும், மெக்கானிக்கலாக போட்டுக்கிட்டே இருந்தீங்க அப்படின்னா நீங்கள் திங்கே பண்ண மாட்டீங்க. ஓகே 1/√2 வருதா, 1/√2 வருது, √2 வருது. ஸோ யூ நாட் திங்க் ப்ராப்பர்லி. And as the mass gets farther from the center, what will happen? The moment of inertia will increase. Appo you see the moment of inertia is increased. The first ரெண்டு ஆப்ஷன் பார்த்தீங்கன்னா I0/8 கொடுத்துருக்காங்க. I know that it is wrong. I0/4 wrong. Third option 8 times I0 கொடுத்துருக்காங்க. Fourth option 2 times I0 கொடுத்துருக்காங்க. So it means we found that this is correct. But I know that even before starting the problem work out பண்ணுறதுக்கு முன்னாடியே எனக்கு தெரியும் இது ரெண்டும் ராங். ஏன்னா லோவர் டென்சிட்டினா மாஸ் வந்து இட் இஸ் ஸ்ப்ரெட் அவுட், இட்ஸ் அவே ஃப்ரம் த சென்டர். இப்போ அவே ஃப்ரம் த சென்டர்னா மொமெண்ட் ஆஃப் எனர்ஜி வந்து அதிகம் தான் ஆகும், கம்மியாகும். Okay. Any other doubts?
No, sir. Understood.
Okay. வேதாந்த், உங்களுக்கு வேற ஏதாவது டவுட்ஸ்? செந்தமிழ் செல்வன் ஒர்க் அவுட் பண்ணி பார்த்தீங்களா?
எஸ் சார்.
ஓகே. நேற்று வந்து ஐ திங்க் வி கம்ப்ளீட்டட் சம் 25 ப்ராப்ளம்ஸ். ஓகே. Around 25 something we finished, I think. These are all easy stuff only, so I'm going to skip some of the things. I will upload the solution after the class. I have taken the pictures. I will upload the solutions from my, working out all these problems. And I will, upload it as a PDF so that it's easy for you. The theory questions நீங்களே try பண்ணுங்க. Maybe we can try some. A thin circular ring of mass m and radius r is rotating about its axis with a constant angular velocity omega. 4 objects each of mass m are kept gently to the opposite ends of 2 perpendicular diameter of the rings. That ring இதுதான் ஆக்சிஸ், மாஸ் வந்து m, ரேடியஸ் வந்து r. ஸோ 4 ஆப்ஜெக்ட்ஸ் ஆஃப் ஈச் ஆஃப் மாஸ் m ஆர் கெப்ட் ஜென்ட்லி. அப்போ என்ன அர்த்தம்னாக்கா, ஸோ இனிஷியலாக வந்து இது வந்து ஒமேகா ஸ்பீடில் சுற்றிட்டு இருக்கு. நவ் தே ஆர் சேயிங் தட் திஸ் இஸ் பிஃபோர், திஸ் இஸ் ஆஃப்டர். So after Lenonaka, they are saying that you are putting 4 masses m, small m. In the diameter epdi, in the diameter epdi. That means I know that they are asking to find the speed, angular velocity. Just like a linear momentum, I know that angular momentum initial is equal to angular momentum final. You can say this is before, this is after. This is I into omega. This is also I into omega. I initial is ring means you should know the formula mr squared. Disk means mr squared by 2. Rod means ml squared by 12. Sphere means 2 by 5. Solid sphere means 2 by 5 squared. Hollow sphere means basic formulas you should remember. Omega initial, they gave it as omega. Moment of inertia final. So in addition to the ring, you have some masses added. So that means ring's moment of inertia plus mr squared for this one. So not the capital M, small m, mr squared. So for this mass, it will be mr squared. For this mass, it will be another mr squared. For this mass, it will be another mr squared, mr squared. So that means it will be multiplied by 4. Omega final is what is asked. That's all. Simplify this, you'll get the answer. I cannot cancel the m because I have a plus here. But r squared is there everywhere. So that means r squared can be cancelled. So m into omega divided by m plus 4m. That is your omega final. That means your answer is m plus m omega divided by m plus 4m. It should be the answer. Okay. The simple logic is moment of inertia you should add for the smaller masses. Very, very easy. More than 50 problems, I think I used this angular momentum before is equal to angular momentum after. So that means definitely you will get some problems based on this. As I told you, rotational motion system, particles and rotational motion is a slightly longer chapter, so you can expect more than 2 or 3 questions in one single chapter. Okay, neat. I think this is also very similar to what we did now. Round disk of moment of inertia I2 about its axis perpendicular to its plane passing through its center is placed over another disk of moment of inertia. Actually, it's a printing error. I think it's I1 rotating with an angular relation omega, the final angular velocity. So maybe I can do that. It's also very similar. I can show you where you can find this in the handbook. I think I showed you in the last class, yesterday's class, but yeah, every day it will get stuck in this page. It will take 2-3 minutes, 3 seconds. Yeah. Where is it? 2 discs will be there, one above the other. Yeah, this one. So this is a problem they're asking, rotating this falling into another disk. Okay. So L before is equal to L after. I1 omega 1, I2 omega 2 initially, and I1 omega dash, I2 omega dash omega final, because once it falls on this, both will become one single object. That means there will not be separate velocities. So that means it will be omega F. And then I can add the I1 plus I2. That's all. So if you know this, you can do this problem. Okay, so all the concepts are already given in the handbook. Only thing, you should take some effort to connect the concepts with the numerical. So I1 omega 1 is correct. Round disk of moment of inertia I2 about its axis passing through which is placed over another disk. So it means omega 1 is 0. They didn't say it's rotating initially. Sorry, omega 2 is 0. Second disk. But the first one is rotating at the speed of omega. So that means I1 omega is equal to I1 plus I2 into omega F. That means if I want omega F, I1 plus I2 will come in the bottom. So I1, this one. You see, this also looks very similar, but you should understand that I1 into omega. So that means this is the correct answer. You see, L before is equal to L after. Again and again and again, you'll be using the same concept. So it's very similar to your M1 V1 plus M2 V2 is equal to M1 V plus M2 V, and V will come. So work power energy collisions படிச்சிருப்பீங்க. If you have one ball here and another ball here, and if it's embedded on this, after collision, let's say it becomes one single object, then you will not have two different velocities. It will be one single velocity. It's the same thing. It has only one single angular velocity. System of two particles having masses m1 and m2. If the particle of mass m1 is pushed towards the center of mass of the particles to a distance d. I think it's a printing error. Distance d. By what distance with the particle? So that means m1 is here, m2 is here. Imagine that the center of mass is somewhere here, assuming this is heavier. So m1 is pushed towards the center of mass of particles through a distance d. So that means they are saying that this is slightly pushed inside by a distance d. Imagine that it's like kept on a rod. By what distance will the particle mass m2 move so as to keep the center of mass of the particles at the original position? So that means the center of mass, they say that it should be in the same place. So how much should I move this m2? Whenever you do not know something, take it as x. This is what is asked. As I told you, I can take this as a starting point or this as the starting point. Doesn't matter, right? So you can take any of them. The center of mass should remain the same. So d minus x. So let's take this as the origin, right? So that means this will remain the same. MRCM is equal to M1 R1 plus M2 R2. M1 plus M2. RCM is the origin. அப்போ இது வந்து 0 ன்னு எடுத்துக்கலாம். M1 is this one. R1 is this distance. So you see it's on the left side, so that means it should be minus. So minus, I don't know this distance. In that case, I can take this. Okay, I can keep this as R1 plus this is R2. So this is R1, this is R2. But then this is on the negative side, so it will become minus MR1. This is on the positive side. So that means this side it becomes 0, so M1 R1 is equal to M2 R2. And from the second equation, second drawing, again this is my MRCM is equal to M1 M1 this distance. I know this is R1 minus D. So R1 minus D. And then I know that I am moving in the negative direction. So that means I should put a minus here. And this is M2 into R2, which is this distance. So which means R2 minus X. So substitute things over here and get the value of X, that's all. So they're asking to find the X. So this side it will become 0. So M1 R1 minus of minus plus, when it comes on this side it will be minus. So M1D is equal to M2 R2 minus M2X. But look at this, M1 R1 is equal to M2 R2. So M1 R1 is equal to M2 R2. So these two will cancel. I want X. So X is equal to M2 comes on this side. So minus M1 by M2 then D. So minus minus cancels, so M1 by M2 into D. So that's the answer. That means if I move this much distance, the center of mass will not change. Actually, I thought X is moving in this direction, so I thought I would get a negative. How come I'm not getting a negative value? R1 minus D, so that is negative. R2 minus X. So this is positive R2 minus X. Okay, X is actually a positive value only. Yeah. Even though you are going this way, I'm doing R2 minus X, so it's already taken care. Any doubts, anybody? Even if you take this as the origin, you will get the same answer. Okay, you can try it with different methods. நிறைய தடவை சொல்லியிருக்கேன், மோர் தேன் ஒன் மெத்தட் கற்றுக்கிட்டாக்கா ரொம்ப நல்லது. ஏன்னா வந்து இப்போ எக்ஸாம்பிள் உங்களுக்கு டைம் இருக்குது, கொஞ்சம் ஒரு எக்ஸ்ட்ரா 1 minute இருக்குது, நான் வந்து இந்த ஆன்சர் கரெக்டாக செக் பண்ணி பார்க்கணும் அப்படின்னாக்கா இன்னொரு மெத்தடில் ட்ரை பண்ணி அதே ஆன்சர் வருதா அப்படின்னு பார்க்கலாம். இன்னொரு மெத்தட் தெரியல அப்படின்னாக்கா யூ டோன்ட் ஹாவ் தட் ஆப்ஷன் அட் ஆல். ஓகேவா? ஸோ ஆல்வேஸ் ரிமெம்பர், லேர்னிங் மோர் தேன் ஒன் மெத்தட் இஸ் ஆல்வேஸ் வெரி ஹெல்ப்ஃபுல். ஸோ நீங்கள் ஹோம்ஒர்க்கில் வந்து இது பார்த்துக்கோங்க. ஹோம்ஒர்க்கில் வந்து டேக் திஸ் அஸ் ஆரிஜின், அங்கேருந்து ஆர்சிஎம் அதெல்லாம் கால்குலேட் பண்ணி 1 hour தான் ட்ரை பண்ணி பாருங்கள். ஓகே, லெட் மீ கெட் சம் வாட்டர். These are all very easy problems, but still, I have seen many students think that it is complicated. So it's actually very easy. So let me show you. It's very, very easy. Wheel having moment of inertia, I கொடுத்திருக்காங்க, about its vertical angle, rotates about 60 rpm. So omega is equal to 60 rpm. So 60 revolution means 2 pi, minute means 60 seconds. So 60 cancels, so I'll be getting 2 pi radians per second. The torque which can stop the wheel's rotation in 1 minute would be, so that means stop the wheel means omega final is 0. Time is 1 minute, so 60 seconds. Torque means tau is equal to I alpha. That means I is given, torque is asked. If I find alpha, then I can find torque. என்ன சார் ரொம்ப காம்ப்ளிகேட்டடாக இருக்குது அப்படின்னா, இட்ஸ் ஒன்றுமே இல்லை, F is equal to ma, mass into acceleration. அதுதான் வந்து ரொட்டேஷன் மோஷனில் ஐ டோல்ட் யூ டு go through the table. Force will become torque, mass will become moment of inertia, acceleration will become angular acceleration. So I told you have to be thorough with this table. The table. Linear versus rotational. Everything is documented here. ஒழுங்கா படிச்சு பார்த்து டவுட் கேட்டிங்கனாக்கா ஐ கேன் ஹெல்ப் யூ. ஓகேவா? So it means how to find alpha. V தெரியும், U தெரியும், T தெரியும். So I can use V is equal to U plus AT. But we are doing rotational motion, which means omega final is equal to omega initial plus alpha into T. Omega final 0, omega initial 2 pi plus alpha into T வந்து 60 seconds. Means alpha is equal to minus 2 pi divided by 60, which is minus pi by 30. Why sir minus அப்படின்னா you are stopping the wheel, which means it's like brake அடிக்கிற மாதிரி. So acceleration வந்து brakeனாக்க deceleration, right? அப்போ நெகட்டிவ் வரும். இது அதே தான் இதுலையும். So you are applying the brakes. It's also tau is equal to I alpha. I is 2 kg meter square. Alpha is minus pi by 30. So it will be pi by 15 is the answer. The final answer, of course, we can ignore the sign because it's negative நமக்கு தெரியணும். So it's like pi by 15 Newton meter. Very simple. Okay. Means I think they are asking you L1 by L2. L1 is I omega. L2 is 2I omega 2 because they said 2I moment of inertia. So IA cancels. I want to find omega 1 by omega 2. So omega 1 by omega 2 will become root 2. This 1 by root 2. So this is given data, this is asked data. So you have to combine, in the information you have to combine it and do it. ஸோ இதில் கொஞ்சம் வந்து ஒர்க் அவுட் பண்ணி பார்த்து என்ன வேணும்னு பார்க்கணும். அதுக்கேற்ற மாதிரி இங்கே அட்ஜஸ்ட் பண்ணி யூ ஹேவ் டு கெட் இட் ஓவர் ஹியர். These are all easy stuff, so you can do it yourself. But this is integration based in 33. Let's try that. A tube of length L is filled completely with an incompressible liquid of mass m and closed at both the ends. So இங்க liquid fill பண்ணிருக்கோம். So length is L, mass is m. The tube is then rotated in a horizontal plane about one of its ends with the angular velocity omega. So at about one of its end, you are rotating this. Then angular velocity omega. The force exerted by the liquid at the other end. So they're asking you how much force is acting on this end from this. So as you spin this, right, I think it will be like a centripetal force, right? And centripetal force is towards the center, and the pseudo force for that will be centrifugal force, which is acting outside. Remember circular motion வந்து நம்ம ஆல்ரெடி டிஸ்கஸ் பண்ணோம். கார் வந்து லெஃப்ட்ல டர்ன் பண்ணுது அப்படின்னா we will try to. Let me close the window. ரொம்ப noisy. So நம்ம already circular motion discuss பண்ணிருக்கோம். When the car is turning towards your left, passengers will get pushed towards the right. Okay, I'm sure all of you will have experienced this, particularly when you are taking a sharp turn. நம்ம எல்லாருமே வந்து will get pushed towards the other side, and that is what is called centrifugal force. But centrifugal force is equal to the centripetal force. Okay, அது வந்து pseudo force மாதிரி. So அதனால வந்து we have to calculate the centripetal force. If I calculate the centripetal force, I can tell the centrifugal force. But the interesting thing here is I cannot take the complete m. ஏன்னா வந்து the m is kind of distributed everywhere. Actually you can do integration, or you can approximately வந்து average பண்ணிக்கலாம். So I think it will be, you can assume that the center of mass is somewhere here. So L by 2 distanceல இருக்கிற மாதிரி assume பண்ணிக்கலாம். Let's try both the methods. Okay, so average method. So since it is uniform இருக்கிறதுனால I can assume that the center of mass is at the center. So entire mass m is acting from this center point. அப்போ centripetal force என்னவா இருக்கும்? F is equal to mv squared by r, which is equal to mr omega squared. But total mass m, length வந்து it's somewhere at the center na assume பண்ணிருக்கோம். The entire mass is acting from here, which means it will be L by 2 to omega square. So I think it will be ml square, m L omega squared by 2. Okay. For double checking, what you can do is, இது கரெக்ட் தானா உங்களுக்கு ஒரு டவுட் இருக்கு அப்படின்னாக்கா then you can do the integration. Integration ரொம்ப ஈஸி தான். So we will assume this small region, a distance of x. இந்த ஸ்மால் ரீஜன் வந்து dxன்னு அசியூம் பண்ணிக்கலாம். இதில் உள்ள இருக்கிற மாஸ் வந்து dmன்னு அசியூம் பண்ணிக்கலாம். It means if I want the centripetal force, a small centripetal force due to the small mass element dm will be dm r is this distance x. Omega square, omega is constant. So if I want to find the total force, it will be integrating this. So that means it will be omega squared is a constant. Integral of dm can be written as, for the total length L, the mass is m, how much it is for a distance of dx. And that will be giving me the small mass dm. Every time we are using this, so nalla pathukam. So proportions, right? Ratio and proportions படிச்சிருப்பீங்க மேத்ஸ்ல. ஸோ டோட்டல் லென்த் எல்லுக்கு டோட்டல் மாஸ் எம்னாக்கா அப்போ டிஎக்ஸ் டிஸ்டன்ஸ்க்கு எவ்வளவு? ஸோ மல்டிப்ளை பை டிஎக்ஸ். That will give me the mass for this small element. That means in place of dm I can put this one. So m by l into dx. So that means x into dx in the x. M by L is also a constant, so I can keep it outside. So M by L omega square. We integrate pannina h squared by 2. I have to integrate from 0 to L. L squared by 2. So L cancel pannina ml omega squared by 2. So you will get the same answer. This is what I said, more than one method நீங்க கத்துக்கிட்டீங்க அப்படின்னா your confidence level will improve. அப்போ ஒரு டவுட் இருக்கு, ஒரு ப்ராப்ளம் எனக்கு டவுட் இருக்கு அப்படின்னாக்கா you can always டைம் இருக்கு அப்படின்னாக்கா you can double check it by the another method. And சில டைம் இல்லை சார் எனக்கு இந்த மெத்தட் வேண்டாம் அப்படின்னு நினச்சிங்கனாக்கா, இல்லை சார் எனக்கு இன்டகிரேஷன் கஷ்டமாக இருக்குது, இது ஈஸியாக இருக்குது அப்படின்னாக்கா இது மட்டும் கற்றுக்கிட்டு போனீங்க அப்படின்னாக்கா that could be a different problem where you have to use integration. இந்த மெத்தடில் பண்ண முடியாதபடி ஏதாவது ஒரு ப்ராப்ளம் கொடுக்கலாம். அப்போது இந்த இன்டகிரேஷன் மெத்தட் தெரிஞ்சிருந்தால் தான் நீங்கள் கான்ஃபிடென்ட்டாக பண்ண முடியும். I think we talked about this in the previous class. Angular momentum will remain the same, LA, LB. So handbookலையும் கொடுத்துருக்கேன், போய் படிச்சு பாருங்க. ஏன்னா பெர்பெண்டிகுலர் டிஸ்டன்ஸ் வந்து சேமாக இருக்கும். ஸோ பெர்பெண்டிகுலர் டிஸ்டன்ஸ் சேமாக இருக்கிறதுனால angular momentum will remain the same. ஏன்னா mass into velocity same, perpendicular distance r சேமாக இருக்கிறதுனால r cross p will remain the same. ஆக்சுவலாக ஆர் சேஞ்ச் ஆகும், பட் இந்த பெர்பெண்டிகுலர் டிஸ்டன்ஸ் வந்து சேமாக இருக்கும். ஓகே, திஸ் இஸ் another important type of problem. இது வேணால் ட்ரை பண்ணலாம். Tatvatika, Vedant, everyone okay? Sindhumal Chelvan?
Yes, sir.
Okay, very good. Malavika, Pontamlarasi? ஃபாலோ பண்ணிட்டு இருக்கீங்களா? எனி டவுட்ஸ்? ஓகே. ஓகே, திஸ் இஸ் அ வெரி இம்பார்ட்டன்ட் டைப். ரொம்ப ரொம்ப ஈஸி மெத்தடு, நல்லா பார்த்துக்கோங்க. யூனிஃபார்ம் ராட் ஏபி ஆஃப் லென்த், இது வந்து எல், ஆக்சுவலாக பிரிண்டிங் எல், மாஸ் எம் இஸ் ஃப்ரீ டு ரொட்டேட் அபவுட் அ பாயிண்ட் ஏ. இப்போ என்ன சொல்கிறாங்கன்னா, ஒரு ராடை வந்து இப்படி வச்சுருக்கோம். ஸோ இங்கே வந்து ஒரு ஹோல் போட்டு இதில் வந்து ஒரு சின்ன ஸ்டிக்கு இன்சர்ட் பண்ணி வச்சுருக்கீங்க. இது வந்து இப்படி மூவ் ஆகும்னு வச்சுக்கோங்க. It can oscillate like this back and forth. Given that the moment of inertia of the rod is about ml squared by 3, என்ன நமக்கு தெரியும்? எண்டுனாக்கா சென்டர்னாக்கா ml squared by 12, எண்டுனாக்கா ml squared by 3. The initial angular acceleration of the rod will be, அப்போது இது நம்ம விட்ட உடனே என்ன ஆகும்? It will start rotating இல்லையா? It will rotate about this point. ஸோ அந்த ஆல்ஃபா என்னன்னு கேட்குறாங்க, ஆங்குலர் ஆக்சிலரேஷன். ஸோ இது ரொம்ப ப்ராப்ளம் மாதிரி தெரியும், பட் ஆனால் ஆஸ் ஐ டூ இட் யூ வில் அண்டர்ஸ்டாண்ட் தட் இட்ஸ் வெரி வெரி ஈஸி. ரொம்ப சிம்பிள் ப்ராப்ளம். யூ நோ தட் ஃபோர்ஸ் டியூ டு கிராவிட்டிஸ் எம்ஜி இங்கே ஆக்ட் பண்ணுது சென்டரில். அதை தான் வந்து இது வந்து ரொட்டேட் பண்ணுது. இந்த ஃபோர்ஸ் தான் வந்து அபவுட் திஸ் பாயிண்ட் இட் இஸ் ரொட்டேட்டிங் இட். அப்போது டவ் இஸ் ஈக்குவல் டு ஐ ஆல்ஃபான்னு ஒரு ஃபார்முலா படிச்சிருக்கோம். டவ் இஸ் ஈக்குவல் டு ஃபோர்ஸ் இன்ட்டு டிஸ்டன்ஸ்னு ஒரு ஃபார்முலா படிச்சிருக்கோம். ஸோ ஐ ஆல்ஃபா இஸ் ஈக்குவல் டு ஃபோர்ஸ் இன்ட்டு டிஸ்டன்ஸ். ஐ வந்து மொமெண்ட் ஆஃப் இனர்ஷியா கொடுத்துட்டாங்க ml ஸ்கொயர் பை 3. ஆல்ஃபா தான் கேட்குறாங்க, ஆங்குலர் ஆக்சிலரேஷன். ஃபோர்ஸ் வந்து mg, டிஸ்டன்ஸ் வந்து L/2. அவ்வளோதான், தட்ஸ் யுவர் ஆன்சர். So 3/2 g and L will come here. So 3/2 g by L. Okay. ஸோ ஒவ்வொரு ப்ராப்ளம்லையும் இந்த அண்டர்லைங் பிரின்சிபல் என்னன்னு கண்டுபிடிச்சிட்டிங்க அப்படின்னா அப்புறம் சப்ஸ்டியூஷன், மல்டிப்ளிகேஷன், டிவிஷன், கேன்சலிங் இதெல்லாம் வந்து இட்ஸ் வெரி வெரி சிம்பிள். அந்த அண்டர்லைன் பிரின்சிபல் தான் வந்து நீங்கள் ஃபிசிக்ஸ் படிக்கிறதா அர்த்தம். ஓகேவா? இந்த சிம்பிளிஃபிகேஷன்லாம் யார் வேணாலும் பண்ணலாம். So whenever, very often they will give you this. So நல்லா பார்த்து வச்சுக்கோங்க இந்த மெத்தட். This is a conceptual question. We can do that. If F is the force acting on a particle having a position vector r and tau be the torque of this force above the origin. இதெல்லாம் கொஞ்சம் 3 டைமென்ஷன்றதுனால கொஞ்சம் வந்து ப்ராக்டிஸ் பண்ணணும். ஸோ இதுதான் வந்து ஆரிஜின் வச்சுக்கலாம், எக்ஸ் ஆக்சிஸ் ஒய் ஆக்சிஸ்ன்னு வச்சுக்கலாம். let's say this is a particle P. இப்போ இதுதான் ஆரிஜின் அப்படின்னா this is r vector. Force வந்து suppose if I say force is acting somewhere here, so let's assume that R and F are in the same paper on this page. Appo you know that torque is R cross F, which is about this point, about this axis. So RF இப்படி இருந்தது அப்படின்னா torque will be this way. I already explained you in the last class. Okay, R should be brought here because tails should be touching each other. Force வந்து இப்படி இருக்கு. அப்போ R cross F, if you use your right hand thumb rule, it will be coming out like this. So that is your tau is equal to R cross F. In last class explain பண்ணேன். அப்போ நல்லா கவனிங்க. வாட் கேன் யூ சே அபவுட் த, இது வந்து பேப்பரில் இது டார்க் இஸ் பெர்பெண்டிகுலர் டு த பேப்பர். தட் மீன்ஸ் டார்க் இஸ் பெர்பெண்டிகுலர் டு ஆர் அண்ட் பெர்பெண்டிகுலர் டு எஃப். டு யூ அக்ரி எவ்ரி ஒன்? எஸ், நோ? தத்வதிகா, வேதாந்த்? following torque வந்து it is perpendicular to R and perpendicular to F. Do you agree or not? Yes or no? யாரும் பதில் சொல்ல மாட்டீங்களா? வேறு யாராவது? செந்தமிழ் செல்வன், தத்வதிகா, what happened to you? புரியுதா இல்லையா?
Yes, sir.
ஸோ டவ்வும் ஆரும் பெர்பெண்டிகுலரா இல்லையா?
Yes, sir. It is perpendicular.
Perpendicular அப்படின்னா which one is correct? Dot product becomes
0.
very good. So that means what will be the other option? What can you say about force and torque? That is also perpendicular. That means F dot tau is also equal to 0. So which option is correct?
Option B.
Okay, very good. Option B is correct. ஸோ இது தெரிஞ்சாதான் இந்த ப்ராப்ளம் பண்ண முடியும். டார்க் பெர்பெண்டிகுலர் டு ஆர் அண்ட் எஃப்னு தெரிஞ்சாதான் இந்த ப்ராப்ளம் பண்ண முடியும், இல்லாட்டி பண்ண முடியாது. This is very similar to that 4 masses நம்ம அட்டாச் பண்ணோம் இல்லையா அந்த ரிங். அதே இது 4 மாஸ்க்கு பதிலாக 2 மாஸ் கொடுத்துருக்காங்க. ஸோ இட்ஸ் த சேம் திங். ஐ திங்க் ப்ளஸ் 4m பதிலாக 2m வரும்னு நினைக்கிறேன். ஸோ ஐ திங்க் திஸ் வில் பி த கரெக்ட் ஆன்சர். ஸோ ஐ லீவ் இட் டு யூ, யூ கேன் ட்ரை இட் யுவர் செல்ஃப். திஸ் இஸ் வெரி சிமிலர் டு தட் 2 டிஸ்க் ப்ராப்ளம். 2 டிஸ்க் நம்ம மேலே இருந்து ஒரு டிஸ்க் வந்து ட்ராப் பண்ணோம் இல்லையா. So that problem. So this is also very similar. You can see many of the regular problems, they are repeating it in many of the years. Torque becomes 0. Torque becomes 0 means alpha becomes 0. Right? Because I told you tau is equal to I alpha. F is equal to MA. When acceleration becomes 0, force becomes 0. When alpha becomes 0, tau will become 0. That means t is equal to 1 second. So nothing very difficult, very easy problem. Okay, this is a very important conceptual question. A circular platform is mounted on a frictionless vertical axle. Its radius is 2 meters, so that means it's a large circular platform. Moment of inertia is given, I is given. Radius is 2 meters. Initially at rest, so it means omega initial is equal to 0. A 50 kg man stands on the edge of the platform and begins to walk along the edge. So he is trying to walk with a speed of 1 meter per second relative to the ground. So this is 1 meter per second with respect to ground. So இது கொஞ்சம் கான்செப்ட் தெரிஞ்சாதான் நம்மளால பண்ண முடியும், இல்லாட்டி பண்ண முடியாது. Time taken by the man to complete one revolution. இது வந்து ஒரு ட்ரெட்மில் மாதிரி அசூம் பண்ணிக்கலாம். நம்ம ட்ரெட்மில்ல நம்ம என்ன பண்ணுறோம், நம்ம நடந்தோம் அப்படின்னாக்கா பெல்ட் வில் கோ பேக்வர்ட்ஸ் இல்லையா. ஸோ ட்ரெட்மில்ல வந்து இந்த மாதிரி ஏதாவது ஒரு பெல்ட் இருக்குன்னு வச்சுக்கோங்க. ஸோ நான் இங்கே நின்று நான் வந்து இப்படி நான் இஃப் ஐ எம் வாக்கிங் ஃபார்வர்ட் தி பெல்ட் வில் மூவ் பேக்வர்ட், ரைட்? So that means you are pushing the belt backwards. The same thing will happen here also. So I am walking forward, but the disc will move in the backward direction, this way. So what is the time taken by the man to complete one revolution? Appo you will be walking in the same place, but ana வந்து இந்த டிஸ்க் வந்து ஒரு ரவுண்ட் முடிச்சிட்டு இங்க வந்துரும். ஓகேவா? So a direct method வந்து velocity is equal to distance by time. So they are asking to find the time. Distance by velocity. Distance will be, it has to complete one full revolution, means 2 pi r distance. Velocity will be the velocity with which the disk will be moving, right? So that means it will be omega v is equal to r omega. So I need to find the omega, or else I say this is 1 meter per second in the forward direction. It will be 1 meter per second in the backward direction. So that means velocity I can take it as 1, but with respect to the ground, this four pi, I don't have that option. Okay. Maybe I have to use velocity with respect to ground, velocity of the person with respect to the ground is given as 1 meter per second. This is person, this is ground, person and ground. relative velocity formula நம்ம ஆல்ரெடி டிஸ்கஸ் பண்ணோம். ஸோ velocity of the person we want velocity of the person with respect to the wheel of the disc. இது வந்து ground. So velocity of the person with respect to the ground minus velocity of the disc with respect to the ground. So velocity of the velocity of the person with respect to the disc, I do not know. So VPD, velocity of the disc with respect to the ground. So I think for that I need to find the rotational motion concepts. Okay. So when this is going 1 meter per second forward, this should be in the negative direction. So it will be in the opposite direction. So that means minus 1. So with respect to the disc, the person is moving at 2 meters per second. With respect to the ground, it is 1 meter per second. That means with respect to the disc, the velocity is actually 2. It's not 1. Two pi seconds. But actually there is a longer method for this. Okay, this is like a quick method. So I just wanted to make sure that you are aware of the quick method first, and then I can help you with the longer one. Longer one, moment of inertia they are given. Calculate the moment of inertia. So I should use angular momentum before is equal to angular momentum after. The problem with computer screens is I cannot see the question properly. No, every time we have to keep rolling this. 40, okay. Initially the platform is not moving, so this becomes 0, and final will be moment of inertia of the disk is 200 omega final. Plus moment of inertia of the man, which is mr squared. 50 into r squared is 2 square. omega, I have to substitute omega here. Actually, if you think about it, you are walking here, right? Center is here. So moment of inertia due to the disk is added, and this is angular momentum due to this man. So angular momentum will be, it's not angular momentum will be mass into velocity. So actually I should not write this one. This is for moment of inertia. This is for the man, right? So this is for the disk. This is for the man, which is radius is 2 meters. Mass of the thing is this one. And this should be velocity with respect to the disk, which is he found it as 2. Right, velocity of the man with respect to the thing is 2. So we'll get a 200 here, 200 here. So omega f will be 1. So omega final is 1 radians per second. And they are asking you to find the time taken for one full complete revolution. Okay. So that means p squared, but I don't know the alpha. So V is equal to R omega. Omega is 1 here. So that means the velocity of the disk will be 2 meters per second. I think that's what we used here. Okay. So from that you can arrive at this. So this is slightly confusing, so try to understand this is for the disk and this is for the man, which means you should use the angular momentum for a particle, which is R into M into V. Okay. So this is slightly confusing, and to make it even worse, they added this, with respect to the ground. So it makes a little more, relative velocity concepts. Only if you know the relative velocity concepts, you can do this. So after this, it's very easy. So V is equal to omega. Maybe this is not required. Omega is equal to theta by T. So T is equal to theta by omega. Theta is for one full revolution, theta is 2 pi. Omega is minus 1, which means time is 2 pi. So that means actually we'll get a minus 2 pi here because it's rotating in the opposite direction. So that's why it will become plus. So that means the time taken will be 2 pi seconds. So that means in both the methods we'll get the same answer. So the previous method, this one, and this long method, both will give you the same answer. Slightly confusing, so take some time and go through it. Forty-one is easy. Can try it yourself. Yeah, this I think it's the same thing, disk 1 and disk 2, and you are putting it face to face. So very similar. So we will take it as I1 omega 1 plus I2 omega 2 is equal to I1 plus I2 into omega f. Okay. So after attaching, they will become one single disk. So that's also easy. This is very similar, right? So we can discuss this quickly. These kind of problems, it may look complicated, but actually it's very easy. Rod PQ of length hinged at the end P. So what this means is, hinged means you have a way to rotate about this point. Rod is kept horizontal by a massless string. When the string is cut, so suppose if I fall down like this. So it's very similar to what we did earlier, the initial angular acceleration. So go back and check. We did mg over here. Mg into L by 2 is equal to I into alpha. I is ml squared by 3. Okay, so go back and check. We already did this problem. So I'm not going to do it again. Yeah, all these things are very similar only. Okay, this is an important type. We can go through the 45th one. A solid cylinder of mass 50 kg and radius 0.5 meters free to rotate about its horizontal axis. Massless string is wound around the cylinder. So it's wound across the cylinder like this. With one end attached over here and the other end is hanging freely like this. Tension in the string to produce an angular acceleration of. So how much tension or force should I apply here to produce an angular acceleration of 2 revolutions? You see, they said revolutions, not radians. That means 1 revolution is 2 pi radians. Very often we will forget this, so make a note of it. To make some mistakes, right? They will do it like this. Same concept, tau is equal to I alpha. Tau is equal to force into distance. So that means I alpha is equal to force into distance. I is moment of inertia for a cylinder will be disk. So disk will be mr squared by 2. Hollow cylinder means similar like ring, it will be mr squared. Since they said solid cylinder, I will take disk formula. Alpha is 4 pi from here. Force is what is asked. Distance is this radius. which is 0.5 meters. Let's all simplify this, we'll get the answer. 50 kg, R is 0.5 the whole square, divided by 2, 4 pi, F 0.5. So how much will that be? 52, so 100 into 0.5 will be 50 pi. 50 pi means 50 into 3, 150. So 157 will be the correct answer. So you see this formula again and again we are using this. But only if you get this idea of this diagram, you'll be able to do this. So practice many problems. Forty-six is a question. So I think we already discussed this. Whenever you have a point, and if you have a particle going at a straight line, I told you the linear momentum about this point will be conserved, right? Sorry, the angular momentum will be conserved. So it doesn't matter it's here or here or here, wherever it is. Even though the r is changing, the perpendicular distance will remain the same. Okay, I even explained you in the last class. So angular momentum L r cross p. This is for a moving particle. About a point, about a fixed point. Some of you might get confused. You know, sir, angular momentum இருக்கும் இது என்னது ஸ்ட்ரெயிட்டா போதா அதுக்கு எப்படி angular momentum இருக்கும் அப்படின்னா an object can be going in a straight line but I can find the angular momentum about a fixed point. அப்போ it will be force into distance ன்ற மாதிரி linear momentum into radius will give me the angular momentum. Okay, so slightly confusing concept. So handbook la enga irukana I told you, so go through that. Get some water. So if I say this is my origin, acting at a point R is here. Let's say F is somewhere here. So I have to there should not be any external torque for angular momentum to be conserved. So external torque listen carefully. For angular momentum to be conserved. No external torques. That means they say that you are applying a force, but then the torque should become zero. So tau is equal to R cross F. Only if the torque becomes zero, the angular momentum will be conserved. Value of alpha for which angular momentum is conserved. So that means, so important concept. So that means R cross F 2 minus 6 minus 12. Alpha 3 6. So equate this to 0 because torque should be 0 or angular momentum to be conserved. யாராவது புரியல சார் என்ன கஷ்டமா லீனியர் மொமெண்டம்ல எக்ஸ்டர்னல் ஃபோர்ஸ் ஷுட் பி 0. வெளியே இருந்து ஃபோர்ஸ் ஆக்ட் பண்ணக்கூடாது, அப்போதான் வந்து மொமெண்டம் வில் பி கன்சர்வ். அதே மாதிரி ரொட்டேஷனல் மோஷனில் வெளியே இருந்து வேற எந்த டார்க்கும் அப்ளை ஆகக்கூடாது. ஸோ தட் மீன்ஸ் எக்ஸ்டர்னல் டார்க்ஸ் ஷுட் பி 0, நோ எக்ஸ்டர்னல் டார்க். அப்போ தான் வந்து ஆங்குலர் மொமெண்டம் இஸ் கன்சர்வ். நேற்று கூட நம்ம பேலே டான்ஸர்லாம் பார்த்தோம். ஸோ தட் மீன்ஸ் there is no external force, only the same person is opening his arms or closing his arms, right? There is no வெளியே இருந்து ஒரு ஃபோர்ஸ் வர்றதில்லை, இல்லை டார்க் வர்றதில்லை. I think this will become 0. So 12, can take it out commonly. So minus 12, 1 plus alpha into j 6 1 plus alpha k. So if I want this magnitude to be 0, right? You should know that the magnitude, when will this become 0? This alone cancel. So square root will go to the other side. 6 square, I can cancel it out. So I think it will be 4. Everyone getting this? I'm just making sure. Let's see if you're getting this correctly. Okay. I can directly say 1 plus alpha should become, this term should become 0, which means 1 plus alpha is equal to 0, which means alpha is equal to minus 1. I think I can directly choose this. But if I want to find other roots, I can calculate that. Okay, so I think if I do this, probably I can find some other roots. So 6 squared 36, so I think it will be like 6 into 2, 2 into 2. Six squared go away. Is this correct? Anybody seeing any errors? So I think it will be 5 1 plus alpha the whole square. 1 plus alpha the whole square is equal to 0. So alpha is equal to minus 1. Yeah. So I think this will be the correct answer. Okay, so this is a conceptual question. Only if you know that torque becomes 0 means you should take the cross product, not dot product, because we are talking about R cross F. Because only R cross F will give me torque. பழக்க தோஷத்தில் dot product எடுத்து 0 பண்ணோம்னாக்கா it will not be useful, right? Because very often we have been doing dot product equal to 0. That will not work here. Okay, so I think we have come something close to 50 problems. We have another 50 problems in this question bank. So my suggestion is try it. Maybe we can do some more problems in the next class. Okay, I'm sure some of you will need some more time to work out this. So I would say try to solve at least up to 75 questions or something, and then we can continue.